Now that we've made our feedback, let's take a look at the one property that's most important here. If we click on Properties page, it's this active state. This active state property says that the correct tab is always going to display to participants. So this means that every time they run, regardless of whether they've responded correctly or incorrectly, they're always going to see congratulations. We want this to be active feedback, so we're going to have to write a little bit of inline script. To do that, let's close out of this feedback window. We'll grab an inline object and we'll put it just between stimulus and feedback in the trial proc. Now, like every object in ePrime, I would like to change the name of this to reflect its function. So this is going to be process accuracy. And hit enter. Let's double click on this to open it in the workspace. What we'll have to do to actively change the slide state. Now what we will have to do to actually change the active state of the feedback object is to do what we call a simple if-then statement. Keep in mind that I'm not going to go into a lot of detail on the scripting aspect of this today, but if you would like to learn more about scripting in ePrime, we have a wonderful series of basic, intermediate, and advanced webinars that handle everything that you could ever want to know about scripting in ePrime. So while I'll give a very basic, very brief overview of scripting, this is not the highlight of the webinar, but is in fact the highlight of a fantastic series of webinars. So if you would like those, please feel free to purchase those. So what we're doing for this is just a simple if-then statement. So what an if-then statement is it's called a conditional statement. So if something proves to be true, or if something evaluates to true or false, then we can have something else happen, which is where the name if-then comes from. Obviously, to start an if-then statement, we will need the word if. So now we need to gain access to the accuracy of the response to the stimulus object. To do that, all we do is type the name of the stimulus object, so in this case, stimulus. Then let's click dot. Now what you see is something that we've incorporated into ePrime called ScriptSense. It actually allows me to quickly view all of the available properties of this object. So for example, if I wanted to know which one this was, I would hover this over ACC and it says reflects the accuracy of the response logged by the input object. Well, that's exactly what we need. So instead of typing .acc, all I need to do is hit enter, and ePrime fills this in for me. So now I have if stimulus.accuracy. So I need to now remember the two different ways that ePrime logs accuracy. It either logs a correct or an incorrect, and in this case, its correct is a 1, incorrect is a 0. This is how ePrime logs accuracy. So let's do our correct condition. So if stimulus.accuracy equals 1, this means that the participant has responded correctly to accuracy. And now we have our conditional statement. So if this condition is met, what is going to happen? We'll do feedback, just so ePrime knows that we're talking about the feedback object, dot, and now we're going to want to look at active state. Active state, if we look here, it says sets or returns the active state of the slide object. This means that we can actually set which state between that correct or incorrect state that we present to participants. So let's show this active state. So let's click enter. So feedback.activeState, and to set it, I'll have to click equal, and then in parentheses I will type the word correct. So now, if stimulus.accuracy is 1, or if the participant responds correctly, feedback.activeState equals correct, which means that participants are going to see this correct slide state. All I need to do to finish this is write the opposite statement. So I will type else if, which just means otherwise, if stimulus.accuracy, so stimulus.acc, equals 0, which is the only other thing it could be, then feedback.activeState equals incorrect. And I will type a quick end if statement right there. So now all this does is it gains access to the one property of ePrime that we are most interested in. In this case, it is the accuracy of the stimulus object, and then it changes the active state of the feedback object depending on the participant's response to this stimulus object. So this concludes the script writing portion for this part of the webinar. If you'd like to pause to catch up or to go over anything that I said, please feel free to pause the webinar at this point. Once we've done our process accuracy inline object, let's go ahead and X out of this. Now, as we can see, our prime, our stimulus, and our feedback are all set up exactly how they should be. The next thing I would like to do is I would like to actually add a block of practice trials. Now, to create a block of practice trials, we actually have a couple of different methods in ePrime. The first method would be for me to create this trial list, these nested lists, and all of these objects again. And this would take another hour of the webinar, and as you can probably see from the timer at the bottom, there's less than an hour in the webinar. So I'm not going to do that. There's actually a faster way to do this. The first thing to do is double-click on the block list. In the block list, let's go ahead and add one more level, and this procedure, instead of block proc, is going to be called practice block proc. And hit enter. As always, ePrime is going to say that the procedure does not exist. Would you like to create it? I'm going to click yes. Now if you take a look at this structure window here, you can see that the block proc is on the top and the practice is on the bottom. This means that ePrime is going to actually run the practice trials after the critical trials, which doesn't really make sense and isn't fair to our participants. So what I can do is I can actually move the practice block above the block proc. To do this, click on the 2 in the ID column so that you're highlighting the entire row. Click on it once more and hold the mouse button down, and then move the cursor up. As you can see, there's this red line that appears at the very top of this list object. If you release the mouse, you see that the practice block comes before the block proc. Now, if I look at my structure window, I can see that this isn't necessarily reflected over here. So the change I made here doesn't look the same over here. To make this match, what I would do is click once in the structure window, just in the white space off to the side here, and click F5, and watch what happens. What clicking F5 does is it refreshes the structure window. So now my practice block appears above my block proc, which is the correct order. So go ahead and X out of this. Now if I double click on practice block, I notice that there's not really anything here. So I need to change that. What I can do is I can actually copy and paste all of these objects into my practice block and make them very quickly. So let's right click on trial list here and click copy. Click on practice block proc, right click, and click paste. Now here's the important dialog. It says the object you are pasting contains child objects. Would you like to paste all of the child objects in addition to the primary object? If I click yes, what it's going to do is it's going to create a new instance of every object in this procedure. So not only will I get trial list 1, but I will also get word list 1, non-word list 1, prime 1, stimulus 1, process accuracy 1, and feedback 1. This means that I'm actually going to create a lot of new e-objects in ePrime, and this is actually way more than I need, since both of these e-objects that I create are going to be doing the exact same function. So let's go ahead and click no. Now if I click no, you'll notice that I did get a trial list 1. However, everything else remains the same. I have word list, non-word list, prime, stimulus, process accuracy, and feedback, none of which are auto-incremented with a 1 at the end, like my trial list is. Now let me show you what the effect of this is. Let's go up and edit the prime object in my practice procedure. Let's add, let's say, a sound out object here. If I add a slide sound out object to this prime object, and I close it, this is my practice procedure, mind you. Let's move down to my actual procedures and double click on it. You'll see that that sound out object is in the prime object. And if I click on one, you'll notice that the other is bolded. This means that I now have 2 instances of the same object, and every change I make to this addition or to this instance of the object also changes this instance of the object. So only be sure to do this only be sure to do this method when you aren't planning on editing anything else about the structure at all, even if I would like to add a new slide object to my practice trials. So let's say I do that. As you can see, that slide that I created in my practice trials also appears in my critical trials as well. And we'll delete that because I don't actually need it. So this is kind of a double-edged sword. The benefit of doing this is you have fewer e-objects in ePrime. This increases your timing accuracy, and it makes e prime have to load fewer objects, so your experiment just runs better. The downside to this is that you cannot make any more changes to this procedure of trials. Even these word lists, I now cannot change, which words are presented during the practice and which one are presented during the procedure. The only thing I can change is this list object up here. So let's actually do that. So let's take our trial list 1 and we'll rename it from trial list 1 to practice list and hit enter. And then in our practice list we're actually going to change the weight from 3 to 1 for everything. That way it isn't weighted the same in our block proc. And let's go ahead and close out of this. Now please feel free to pause the webinar. What we just did was create a practice trial. This showed you how to copy and paste objects in e prime. We showed you the difference between copying child objects and not copying child objects, and how to edit the weight value of an object. Once we've created a practice procedure in e prime, the last thing that I want to do is I would like to get data about this whole run of the experiment. Now what we find is that people would like to get accuracy for the entire experiment. So how often did they respond correctly, how often did they respond incorrectly, and what was their overall RT for the entire experiment as opposed to just one block of trials. Now to do this, we're going to need to use something called a summation object. A summation object is a script-only object in e prime that holds different values of data. So whichever data you specify, it then allows you to format and run different descriptive statistics on this data on the fly. So I can actually print out the mean response accuracy to my edat file without having to configure that elsewhere. Now, we did go over a little bit of scripting here when we did our process accuracy. However, if we need to do anything more intensive than that, and you actually don't really know where to start from, we have a great resource for scripting in e prime. To find it, click on Help in the menu bar here, and click on eBasic Help. It should bring up this help program. eBasic Help is our repository of the entire eBasic language. This is where we keep all of our information on eBasic, and if you click through these folders you can see that there's quite a lot of it. eBasic Help is huge, and each and every one of these articles is really great. It contains an example, it contains the proper syntax for each one of these things, and it contains a brief description of what these are. So for example, if I'm using my Echo client and I would like to add an Echo client, we have the syntax at the top, a description, we have each of the parameters and exactly what they mean and what data type they are, some comments, and more importantly, and I think most helpfully, an example at the very bottom. So we're going to actually find one for a summation object. Now what we can do is we can, scroll through all of these objects here and try to find a summation one, but I recommend clicking on search as it's the easiest way to navigate through eBasic. And let's go ahead and in search, let's type summation. If you hit enter, you should see summation object right here. Let's click on the topic and we will click on any one of these, let's say add observation. So our syntax is summation.add observation, but more importantly let's look at the example here. So it tells you enter the following script into the users tab of the script window. So let's do that. Let's go into the script window, click view, and then script. Now the script window in e prime, if you save or compile your experiment like I'm going to do right now to demonstrate, so I save and then compile my experiment. As you can see, the script window is a full listing of all of the script of e prime. So all of the objects that I have here are turned into script. And as you can see, even my script that I wrote is turned into part of the script. However, if I click on User tab, this allows me to define global variables. Global variables are variables that are used throughout the entire experiment. We of course go into this in more depth in our scripting webinars. The global variables that we would like to create in this instance are two summation objects. One summation object that handles accuracy for our entire experiment. The other one handles response time mean for the entire experiment. So I'm going to define a variable. We do this with a dim statement. Again, we go into these and much more in our scripting webinars. This particular variable is going to be called overall RT. And this is defined as, and you can see script sense again, a summation object. The next one is dim, and let's call this one overall ACC for overall accuracy. We will define this as a summation object. We have our two objects in our user script. Let's go ahead and jump back to this eBasic example. Now it says, enter the following into the post-stimulus inline object. Now what that means is this actually refers to a very specific sample that comes along with eBasic help, called eBasic help sample. Right here, eBasic help example.es2. Now what this is referring to is actually an example experiment that comes along with eBasic, called eBasic example.es2. They're very specifically named inline objects, but all we need to do is just create our own. So for this one it says post-stimulus inline, and this particular experiment, the post-stimulus inline is going to come right after instructions, and we're just going to call this one init. This just stands for initialize. Let's go ahead and double click on it, and let's refer back to eBasic help. As you can see here, eBasic help says set correct times equal to new summation. So this means I need to take my summation objects here, and I need to make them equal to new summations. So I will do set overall RT equal to new summation. This is basically just telling E prime that I am now starting a summation object at the very beginning of the experiment. And I will do set overall ACC equal to new summation. There, now I have both of my summation objects set. So let's go ahead and look back in our eBasic help, and it says enter the following into the after inline object. So correct times dot add observation, and then the observation that I'm adding. So in this instance, if I look here, I'm going to add RT and ACC to both of these summation objects. So let's go ahead and double click on process accuracy, and just after my end of statement, let's hit enter twice, and I will type overall RT dot add observation. As you can see, that's the first one in script sense, so we'll just click enter, and the observation that I'm going to add for overall RT is stimulus dot RT, as I'm accessing the reaction time value of the stimulus object. Similarly, I'll do overall ACC dot add observation, and my observation will be stimulus dot ACC. Now both my summation objects are being actively updated with the reaction time and accuracy value of my stimulus object throughout the entire experiment. So now that I'm doing this, I have to actually use it. So let's scroll down to the bottom of the experiment, and just before the goodbye object, let's put one more inline. This inline is going to be called report statistics. The purpose of this is going to be to take our two summation objects and put them into a usable manner. In this case, we're going to set them to the value of an attribute. So, like I set attributes in any of these list objects, I can also set attributes in script using the c.setAttrib statement. So I will do c.setAttrib. As you can see, it's highlighted there. The attribute that I'm going to set, I can either use this to update an existing attribute, or I can create a new one, which I'm going to do. This one is going to be called mean RT. And then a comma, and then I will want the value. So the value is going to be overall RT dot mean. The next one, I want c.setAttrib mean ACC, comma, and then the value I want is overall ACC dot mean. So it's going to take the mean of the two summation objects that I made and print it out here. Now, once I've done this, I can actually have this just print out the way that it's going to be. And for this one I'm just going to get a number, and for this one I'm just going to get a number. And they're not actually formatted. But there's an easy way to do that in E prime. So my mean accuracy I would like to present as a percentage. So out of 100%, how many percent did they get correct? You can actually format this by using in E prime what we call the format function. The format function is accessed, and then type the word format, and then a bracket. Now, there are two properties of this. The first property is what you're formatting. The second one is how you're formatting it. Overall ACC is what we're formatting, so let's go ahead and click comma. And then the second property is how we're formatting it. Now we're going to format this as a percentage. E prime actually has a shortcut for this. You can access this by typing a quote there, typing the word percent, and doing a close bracket. So now E prime is going to format overall ACC.mean as a percent. So whenever I display this, it's going to say 100% or 50% or however well I did, instead of just a number. So let's do the same thing for mean RT. Now it doesn't make sense to display mean RT as a percentage, but it does make sense to present it in milliseconds with a leading 0. To do that, I would add my parentheses there again. I would add my quotation marks there again. Now to do this, I would add my quotation marks again, and the first thing I will do is my leading 0, and then a dot, because the 0 will represent the seconds, and then I just put 2 number signs after that. So now this is going to present this in a rounded up version in milliseconds. And I will put my last parenthesis there just to close that statement. So now that I've created those attributes, let's go ahead and reference them in this goodbye object. So I would click enter 2 times after goodbye, and I will put your overall reaction time was a colon and then an attribute reference, and as you can see, our mean RT is here, and then your overall accuracy was then a colon, and then as you can see, mean.acc is right here. So this is how we are able to take statistics in E prime, actively collect on them, and then display them. And now that they're set as attributes, these are also going to display in our edat2 files at the end. So if you'd like to pause the experiment now, this demonstrates how to create a summation object in E prime, perform very simple descriptive statistics on that, format them however you would like, and then use those formatted summation objects as feedback on any sort of object that you would like. So let's go ahead and close out of all these windows. So this concludes our eStudio portion of this webinar. What we're going to move on to now is the eMerge portion of the webinar. The eMerge portion of the webinar is going to demonstrate a more advanced way to merge your data files. So let's go ahead and begin by opening up eMerge. We'll dismiss a quick reference window. Now if I take a look at this folder, the one that you should have gotten as well, our data is actually presented by participants. So each participant has his or her own folder, and each folder contains all of the data for that participant. I know some labs like to put their data in this particular structure just to help clean it up. Now, let me show you the problem with this at first. If I were to click on the folder tree here, I click on my intermediate webinar, I don't see any data here. I don't see any of it, and when I try to merge it, there's nothing here to merge. Even though I have all of my data, and as you can see they're in this data folder here, I can only access them one at a time. So if I click merge, all it's going to merge is just one data file, and that's not a merge at all. So what I can do is something called a recursive merge, and you can get to recursive merge by clicking on this merge button here, and instead of standard, clicking on recursive. This actually gives you much more control over what is being merged. And what this does then is it not only checks the current folder, in this case our intermediate webinar folder, but it also checks every subfolder within that folder. So in this case it'll check data, participant 1, participant 2, participant 3, participant 4, and participant 5. It's going to check all of those subfolders for edat files and will merge all of them to the target location, which is our intermediate webinar folder, into one large data file. So let's go ahead and click next as on recursive merge. So it says select folder, in this case it's going to be our intermediate webinar folder. Then it says only merge files selected in the following format. I'm going to choose edat2. But if I wanted to merge two merge files together, I could do that. If I wanted to merge e'Prime1 and e'Prime1 files together, I could do that. If I wanted to merge e'Prime1, e'Prime2, and every type of data file under the sun, I can do that as well. In this case, I'm just doing e'Dat2. Now, if you've ever merged data for a pilot study, or if you've ever preliminarily run data analysis and decided that you'd like to rerun a merge, you'd know that this is a little difficult to do because using that Select Unmerge button only highlights unmerged files. However, you can specify here that I can select Never Merged, Already Merged, or All Files regardless of merge status. So if I do all files, regardless of whether these participant files have been merged into something else before, they'll get merged into my newly created file. So let's go ahead and click Next, and in this I'm going to just call it Intermediate Merge. Intermediate Merge, and click OK. Again, it says this does not exist. Would I like to create it? And I will click Yes to create it. For number of files found, it actually searched all of my subfolders, and it found all 5 of my data files, and then files merged was 5, files not merged was 0. This is perfect, so let's click OK. So now that we've merged all these files, let's go ahead and take a look at them. Let's go ahead and double click on Intermediate Merge, and there's all of my data. So now as far as data analysis is concerned, I want to demonstrate 2 things. The first thing is this arrange columns. We find that a lot of people end up using this. For arrange columns, let's go ahead and click on Remove All. So now none of the columns show up in the eDat file, and now I'll just get the columns I want. So I will show Stimulus Accuracy, Stimulus RT, and let's go ahead and find that congruency attribute that we made. And click OK. So now we only see the accuracy, the reaction time, and whether it was congruent or not. Now if I want to, if I take a look at my data here, I find that I have quite a few outliers. So on the whole, the reaction time seems to be generally stable. However, if I have this particular value here, this 4 seconds to respond, that's really going to throw off my data in favor of an incongruent trial. I can actually filter this out. So if I click on Filter, first I find the column that I would like to filter. In this case it's going to be stimulus.rt. And then checklist. So in checklist I can select all of the values that I would like to filter out. So in this case I would like to filter out that 4000 value, which is down here. There's a couple of them. This could also be done if you figure out what, so many standard deviations away from the mean are. You can filter it based on that. If I click OK, as you can see, it only shows my checklisted ones. However, if I select all of them, and you can quickly and easily select all of them by selecting the first one, scrolling down to the last acceptable value, clicking Shift, and then clicking in the checkbox. It actively updates all of those. If I click OK, it'll then show me that, there we go, and I'll click Close. It then shows me all of the values that I've allowed and does not show me any of the ones that I did not allow. I can actually scroll down. See, the 4000 values no longer appear. So now, if I click on Analyze, I should have a better idea of what this is without any of those outliers. What I'm going to do is I'm actually going to name this analysis, and I'm going to show you why in a second. I'll name this analysis RT by congruency. Now what I'm going to do is I'll take stimulus.rt and I will put it in my data. As you can see, this is going to be summarized by the mean, and I will find that congruent attribute, and I will make that the columns. Now I'm going to click Save Analysis, and I'm going to actually save this into my intermediate webinar folder called RT by congruency, and I'll click Save. So now this is actually very helpful. What a lot of people find that they do is they will run pilot subjects. They will analyze their pilot data just to make sure that the trends are favoring for their hypothesis. And then once they've run their pilot data, they can then apply this same analysis that they've run to their real data. Now, instead of figuring out what you did a couple months ago or a couple of weeks ago after collecting your data, you can actually just load the analysis file that you want. Those are saved as .anl files. And if we double click on RT by congruency, it automatically fills everything in, including that filter that we placed on this data. So then if we click run, we can see that congruent trials were actually much faster than incongruent trials. Therefore, my hypothesis was tested. This is great. So that concludes all of the content for the webinar for today. If you have absolutely any questions, please feel free to go to support.pstnet.com. We are more than happy to answer any questions that you might have there. Please feel free to try out any other of our wonderful webinars. They are all very well done, and they'll demonstrate very important properties in ePron. So thank you very much for attending the webinar today. I hope you enjoyed it as much as I did.